Welcome to this new video. As I promised in the previous video, this is an example of a rotation matrix, and I want us to solve this. You are given this matrix C, and the question is, check that C is a rotation matrix. And of course, the second question is to find the angle, but to obtain the angle, we just have to use the first question, okay? All right. To check that C is a rotation matrix, we basically need two steps. The first step is to show that C is an orthogonal matrix, and the second step is to find the determinant of the matrix. If the determinant is equal to 1, you conclude that the matrix is a rotation matrix. Okay? All right, let's start with the first step. First step is orthogonality, and the second step is the determinant of C. Okay? So for the first step, you have two options. The first option here, you can show that C times C transpose is equal to the identity matrix. Or for the second option, you can show that the matrix, the vectors forming the matrix C are mutually orthogonal. What does that mean? For the second point, here you can show that V1, V2 are orthogonal, and you can also show that V1 and V3 are orthogonal, and V2 and V3 are also orthogonal. Okay, this is the first step. And the second part here, you have to show that the norm of each vector is 1. All right, so either you choose this first option or the second option, there's no problem. They are very simple, okay? So let's look at this first. C is, so if you multiply this by the transpose, C times C transpose. For the transpose matrix, the first row will become here the first column. The second row will become the second column, and the third row will become the third column. All right, this means we have, so if you multiply this, you start with this, you choose to start with this first column here, you multiply the first row. If you rearrange this, you obtain 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? So this is the first option. The second option is V1 and V2. You cross multiply this, you see that you obtain 0. You do the same for V1 and V3. You obtain exactly 0. And the last one is V2, V3 is also 0. You just have to check that. It's very simple. V2, V3, this and this is square root of 13, of 12. Here is minus square root of 12, and here is 0. So you see that this will give you 0, okay? So the norm of V1 is 1 over 3 plus 1 over 3 plus 1 over 3. This is 1 over 3 plus 1 over 3 plus 1 over 3. This is 1. You do the same. V2 will give you 1, and V3 is also 1. All right, we just used two different methods to show that the vector C is orthogonal. Now let's look for the second step. So the second step here is to find the determinant of the matrix C. But as I can see here, to obtain the determinant of the matrix C is not difficult at all. I can also do some Gauss reductions here to make things easy, okay? So I want to make this 0, this element, this entry 0, and this entry also 0. And I can use the first column, the first row, sorry, to make the second row, the entry of the second row, the first entry of the second row 0. So we have the matrix is 1 square root of 3 minus 1 over square root of 2 minus 1 over square root of 6. For the second one, if we say R2 will become R2 minus R1. Okay? This and this is 0. This and this is 2 over square root of 2. And this minus this one is just 0. Also, we can do the same for this one. We take R3 minus R1. This is 0. 0 minus this is 1 over square root of 2. And the last one, this minus this is 3 over square root of 6. So let's find the determinants of this matrix. So the determinant of this matrix is just, if you use the first column, this is 1 over square root of 3 multiply this times this. So this is 2 over root 2 times 3 over root 6. So this is 6 over square root of 36. The square root of 36 is 6. So 6 over 6. This is 1. Okay? So we have shown that the determinant of C is equal 1. So we have done with this. We can therefore conclude that AC is a rotation matrix because, first of all, it is orthogonal. Second, the determinant is 1, as you can see here. Okay? Now, let's look at the second question, question B. You are asked to find the angle of rotation. Okay, here, remember that the rotation matrix in R3, if it's a rotation with respect to the x-axis, y or z-axis, it doesn't matter. But for the x-axis, we have 1, 0, 0, 0 cos theta, minus sine theta, 0 sine theta, and cos theta. What is the trace of this matrix? So if you take the trace, r theta is equal 1 plus 2 cos theta. What is the trace of this matrix? Is 1 over root 3 plus 1 over root 2 plus 2 over root 6. Okay? So from here, we want to solve for theta. It means cos theta is half of 1 over root 3 plus 1 over root 2 plus 2 over root 6. Okay? So you can use your calculator to obtain this. The value of cos theta here is, so we know cos theta is given by 0.55 here. Then theta is r cos of 0.55. This gives you something like 56.6 degrees. So we have solved this example, and as you can see, it's very simple. We have to show that it's a rotation matrix. 2 steps. We have to show that it is orthogonal, and the second step, you have to show that the determinant is equal 1. And for the second question, we have to find the angle. We use the fact that we know the trace of the rotation matrix. It doesn't matter whether you are using the x-axis, the y-axis, or the z-axis. So you obtain the same trace, okay? You obtain the same trace, and the trace of this one is given here. From here, we are able to solve for the angle theta. All right. I hope you understand this. Thank you.